Welcome. In this video, we are going to find the temperature of the sink and the source. The question says, a carnot engine converts 1/5 or 1/5 of the heat that is absorbed from the source into work. When the temperature of the sink is reduced by 300 kelvins, the efficiency is doubled. Calculate the temperature of the source and the sink. So here, the data that we've been given is when the source or when the temperature of the sink is reduced by this, then the efficiency doubles. So let's try to carry out some analysis here. So let us analyze maybe under the data. So the data that we've been given is the efficiency of the machine, okay, which is 1/5. 1/5, this is the efficiency. Then when T source, okay, T sink, sorry, minus 300 kelvins, then the efficiency doubles. So it means that it is going to be 1/5, which will be 2/5 when this is when the T of the sink, when the temperature of the sink is reduced by this, the efficiency goes to this. So now let us try to see how best we are going to find the temperature of the source and the temperature of the sink. So we know that efficiency is calculated by the T, so let's call this T source minus T sink over the T source. T source. So from here, let's make some assumptions. Let Ti and Tf represent T sink and T source, respectively. So these are the value, these are what we're going to use for the temperature of the sink and temperature of the source. So from here, let us proceed. Let us proceed and see how we are going to find the solutions. So here, the efficiency is equal to the Tf minus Ti over Tf. But the efficiency that we've been given is 1/5 is equal to the Tf minus T initial or Ti over the Tf. So from this, we can make n of this the subject simply by cross multiplying. And what we're going to have is our Tf is going to be 5 Tf minus Ti. So from this, what we're going to have is 5 Tf minus 5 Ti. So this is Tf. So from here, we can say Tf minus 5 is equal to negative 5 Ti. So from this, we are going to have negative 4 Tf is equal to negative 5 Ti. And from here, what we're going to have is over 4 over 4, negative, negative. So this and this will cancel, and we're going to have the Tf is going to be 5 over 4 Ti. So let us call this equation 1. And now from here, when the temperature is reduced by 300, when the temperature of the sink, when the temperature, so meaning when Ti is reduced by 300 kelvins, then the efficiency doubles. So it is going to be our 2E, which was this one. So from here, we are going to have efficiency is equal to the Tf, Ti, Tf. And when the efficiency doubles, when it doubles, we are going to have 2/5 times 2, which will be 2/5. So this will be the efficiency. So we're going to have 2/5 is equal to Tf, Tf. So from here, when this one, it is in fact, it doubles when this is reduced by 300 kelvins. Okay, so from here we can even simplify it to be 2/5 is equal to Tf minus Ti plus 300k over Tf. So from here, we can even cross multiply, and we're going to have, so this is 2 Tf. So we're going to have 2 Tf is equal to 5 Tf minus Ti plus 300k. Then from here, we're going to have 2 Tf minus, okay, is equal to 5 Tf minus 5 Ti plus 1500. 5 times 300, so this one, k. And from here, what we're going to do is we are going to take this on the other side. So 2Tf minus 5Tf plus, when it crosses the equal sign, 5Ti is equal to 1500k. And from here, what we're going to have is negative 3Tf plus 5Ti is equal to 1500k. So from here, we know that Tf is equal to, from the first equation, we know that Tf is equal to 5 over 4Ti. So if we put this, so let us call this equation 2. Okay, if we call this equation number 2, so 1, this was equation number 1. So 1 into 2, what we're going to get is negative 3, then the Tf, 5 over 4 Ti. Okay, Ti, then this is plus 5 is equal to 1500k. So this 3 times 5, that is the negative 3 times 5, we're going to have negative 15 over 4. We're going to have negative 3.75 Ti plus 5 Ti. This will give us 1500k. So if this is added to this, what we're going to have is added to a bigger positive value. So it is going to give us a positive. So 1.25 when we divide throughout, and what we're going to get is Ti is equal to 1200 Kelvin. So this is the value for the Ti, and then let us find the value for the T source or Tf. So our Tf is equal to 5 over 4 Ti. So this is going to give us 5 over 4 times 1200k. So here, what we're going to have is 1.25 times 1200k. So this is going to give us a 1500k. So this is the Tf. And from the assumption that we made just at first, we said the Ti and the Tf will represent the the temperature for the sink and for the source respectively. So the T source or T sink is equal to 1200k, and the T source, this will be 1500k. So this